And for our last example, we have example 7, which is Janice deposits a lump sum of $10,000 followed by payments of $200 made into an account that earns 6% compounded monthly for 30 years. In 30 years, she begins withdrawing $2,000 from the account. And so everyone, what we need to do is take a moment and pay attention to what's happening to Janice here. So Jana is depositing money. So the value is going up. $200, and that was $10,000. That's a lump sum. That's going to be compound interest. In addition to that, she's making payments of $200 per month. The value is going to be going up. That's going to be the future value of an ordinary annuity. And she does that for 30 years. After 30 years, she starts withdrawing $2,000 from the account each month. And the value of that's going to go down, which is going to make it a present value of ordinary annuity. So we are going to have 3 different equations for this one. We are going to have the lump sum of $10,000 that's growing. We're going to have the annuity that's growing. At the end, when we figure out what both of those are, we're going to add those together. And then that's going to be the amount that we start with for our present value of ordinary annuity, where she's going to be taking money out. And so again, important to understand, everyone, it is possible to have both compound interest and a future value of ordinary annuity going at the same time, which we do in this case. And this is kind of the beginning of some of the more interesting problems that we're going to do in this course. So like really planning out future. And so I do need the other formula to get started here. I need the compound interest formula. And I'm actually going to pause everyone and take some time to write some things down without doing it on the video. Okay, and so you can see what I've done, everyone. I've set up my compound interest portion of this. I've set up my future value of ordinary annuity portion of this. And I've set up my present value, which is going to be when she starts withdrawing money from the account. So again, these 2 top ones together are going to get added together to be the total amount that she has to draw from down here. So let's run through this problem, everyone. I know it probably feels a little bit scary at this point, but it will be okay, I promise. So Janice deposits a lump sum of $10,000. It's going to grow at 6%. The M is the number of compounding periods. It's compounded monthly, so 12 times for 30 years. I is R over M, so 0.06 over 12. And MT is going to be 12 times 30. So my 0.06 divided by 12 is going to be 0.005. So compound interest for this portion, everyone, we are going to look for the future value of $10,000. Put in a fund at 6% interest for 30 years. And so our N is 12 times 30 is 360. So I'll go to Wolfram with that. That's equals 10,000 times 1 plus 0.005 to the power of 360. So her $10,000 is going to grow to be $60,000. And some change. So that grows to be $60,225.75. That's just part of what Janice is going to have. So I'm going to highlight that for myself. This is the compound interest piece from the $10,000. Then as we read along in the problem again, everyone, it is followed by payments of $200 made monthly. So now we have an annuity, which is a future value of annuity because the value is going up. And all the other numbers are basically going to be the same. So our $200 is going to draw 6%. It's done monthly for 30 years. And so the R over the M is going to be identical, so I'm just going to go straight to 0.005. and the M and the T are going to be identical, and so that's going to be 360. So in my formula, I've got S equals 200 times 1 plus 0.005 to the power of 360 minus 1 over 0.005. So run up here and grab my future value of ordinary annuity formula. And we can see that we're making $200 payments. Our I is 0.005. And N is 360. And this is going to grow everyone to be $200,903.01. Okay. Just checking to make sure everything looks right. It looks like it does. And so again, everyone, those two put together are going to be how much is available in this fund 30 years later when Janice is ready to go about her retirement or do her business or whatever she's doing in this problem. So in 30 years, she begins withdrawing $2,000 from the account each month. And so what we need to understand is that as we get down here to the present value of ordinary annuity, she has both of the things that I highlighted in green put together in that account. And so we need to add the 60,000 and the 200,000 to get what the present value of that annuity is. And so here on the side, I'm going to do $60,225.75 plus $200,903.01. And I get a total value here of $261,128.76. That's not bad considering that she was only putting away $200 a month. And again, up here at the beginning, her $10,000 that she invested turned into $60,000. So she gained about $50,000 on that one, and then gained a huge amount on the annuity as well. So she's sitting pretty good here. She wants to withdraw, so payments coming out of the account of $2,000 each month. And the rate is going to continue to be 0.06. The M is still going to be 12. The T is what we're looking for. We don't know how long this account is going to last. And so our R over M is still going to be 0.005. And MT is going to be 12 times the number of years. So we have, in place of S261,128.76. For R, we've got 2,000. Should probably move that down a little bit so that it sits a little bit better in the equation. And then I've got 1 minus 1 plus 0.005 to the negative 12t over 0.005. Okay. I almost grabbed my phone to do the calculator on there. That's not going to be very helpful. So get my formula for present value of annuity because the value is going down now. She is taking payments out of this account. 61128.76, and the amount that she's withdrawing each month is going to be $2,000. I is still 0.005. And our N is going to be 12t. So it looks like, everyone, that this account will last for about 17.7 years. I'll carry out the decimal places. 17.7 676 years. And so I've got a little bit of space left here at the bottom of the page, everyone. I'm going to try and squeeze my answers to these parts in there. So the account will last for 17.676 years. All right. We had some additional questions here. How much money did Janice put into the account? And so, well, going back up here, she started with $10,000. Then she put in $200 every month for 30 years. So I'm going to find a space here to do this math so that I can still have everything on this one screen. If I had paper and pencil, I would obviously be just moving on to another page. But she started with $10,000. Then she kept going with $200 every month for 30 years. And so we'll see what that amount that she contributed to the account was. So 10,000 plus, and you can use Wolfram for this. I'm just going to use my phone. She put in $82,000. So the account will last for 17.676 years. Her total investment was $82,000. And the account grew by, let's see what the total payout was. And so the total payout, I'll need another little blue box up here to do some math. The total payout is going to be the number of times that she received a payment times the size of the payment. So what do we got? She's taking out $2,000 a month. And so $2,000 every $2,000 12 times a year times 17.676 years. And I think I'm going to need a bigger box. So I'll take care of that right now. And again, everyone, I would hope that you would organize your work a little bit better than this. I'm just limited to the size of the page that I have here. So on my phone, again, I'm going to do the math for this. So 2,000 times 12 times 17.676. Dang. $424,224 is the total amount that she was paid out. So I'm going to add that statement in here. Her total payout is $424,224, which is nuts. And the account grew. Well, she only put in 82,000 and she is taking out 424,000. So that's a difference of about $340,000 that Janice made for doing nothing. That's pretty insane. So the account grew by $340,000. And so again, there's a couple things I feel like we should highlight throughout this, everyone. I'll do it with a yellow. The $10,000 turned into $60,000. In addition to that, she put in $200 a month, and that turned into $200 and some thousand. Together, those amounted to $261,000. But because she took payments out slowly in the amount of $2,000 a month, every time she took a payment out, what was left continued to grow. And over time, that $261, even though she was taking out $2,000 a month, lasted long enough to produce $424,000. So just in the time that she, let's call it retirement, just in the time from retirement to the fund drying up, she made about $160,000 just because, again, she was taking money out slowly and letting what was left in the account continue to grow. I love these problems, and it makes me wish I had started saving when I was younger.